Hi guys! For this video, ang pag-uusapan natin is the shear strength of sections. Okay? So the shear strength of steel sections class is defined by Section 507 of the National Structural Code of the Philippines. So if you have your NSCP, diba yung Section 504, tension members, Section 505, compression members. So diba, naiisa-isa na natin yung mga provisions sa NSCP. Section 506 ay bending. And ngayon, nasa section 507 na tayo, which is shear. Pero madali din lang naman kasi yung mga provisions doon. The general formula for the nominal strength of the section is ito. So, the nominal shear strength is equal to 0.6 Fy AW CV. So, ito yung gagamitin natin. This is NSCP equation 507.2-1. Where Fy is of course the yield strength of the section, and yung AW natin, so itong AW is simply D times TW or the area of the web. Okay, so pwede natin yan i-illustrate, no? Halimbawa, mag-drawing lang tayo ng simpleng I-beam, no? So for instance, I-beam tayo ngayon. Oops, ang pangit nung gawa ko. No, erase ko lang siya. Ayan. So, pen. Saan na yung mouse pointer? Halimbawa, may I-beam tayo ngayon. Tapos, napaka-self-explanatory naman kasi class ng formula. Given yung depth of the beam, at the same time, yung thickness of the web. So, by definition, ang AW is equal to DTW kasi ito yung i-consider natin dyan. Itong buo. Diba? Meron tayong depth tapos the thickness of the web. So, diba? Napaka self-explanatory naman nun. And besides pala, gusto ko lang i-emphasize, no? Kapag may butas yung web natin, syempre, ibabawas mo lang yon. Halimbawa, no, may butas ito, may butas dito. The general rule is, yung AW is yung magiging net area of the web. So, reduced mo na lang yung butas. Kaya nga, diba, katulad nung nasabi ko sa last chapter, ang strength or ang I-shape class, may purpose ang flange and may purpose ang web. Yung flange is usually para yan sa mga bending, and yung web is para sa shear. So, erase ko na to kasi may lalabas pa dyan na mga words. Okay? So, sige. Continue tayo. Okay. So, the value of CV, so ito kasi yung CV, nakadepende siya sa provision din ng NSCP. At the same time, class, ngayon, sa shear strength, pwedeng maiba yung value ng reduction factor, which is for LRFD, and the factor of safety, which is for AST. So, i-discuss na natin yon. So, yung unang case, ito yung pinakamadali. If the webs of rolled I-shapes member with H over TW less than or equal to 2.24, the square root of E over Fy, so yung CV daw ay automatic ng 1.0. Para lang yan sa mga I-shapes. Okay? So again, ang CV is automatic ng 1. At the same time, yung ating LRFD reduction factor is 1. So technically speaking, walang reduction na mangyayari. And ang factor of safety natin sa ASD is 1.5. So kapag mga I-shapes na ganito yung mangyayari. Another case is kapag yung web natin of all other doubly symmetric shapes and singly symmetric shapes and channels. So, itong portion na to is applicable ito sa mga I-shapes na hindi pumasa doon sa previous case, sa mga channels, sa single angles, sa double angles, and even sa structural T's. So, kung ang inyong shape is I, which is very common, so, pwede mo muna siyang i-check doon sa case 1. Tapos, may possibility mapupunta siya sa case 2 which is ito nga. Pero kapag ang shape nyo class ay channel or structural T, dito agad yan sa case 2. Nakukuha nyo yung point ko. Again, kapag ang shape na i-consider nyo mga channel, angle, tapos T's, tapos yung mga I-shape nga na hindi pumasa sa case 1, dito agad sa case 2. So dito, nahahati yan sa tatlong scenario but the general rule, kapag nasa case 2 ka na, ang reduction factor nyo ay 0.90 while ang factor of safety nyo is 1.67. Okay? So, sana walang nalilito doon. No? Sa case 1, iba ang reduction factor. Sa case 2, iba ang reduction factor. However, yung value ng CV is kapag yung H over TW is less than or equal to 1.10 the square root of KVE over FY. So, ang CV natin dito ay 1. So, parehas lang ba siya nung case 1? No. Although ang CV natin dito is 1, 'di ba? Still nabago yung reduction factor. So 0.9 then 1.67. So dito, kapag yung ating H over TW is between 1.10 the square root of KVE over FY and 1.37 the square root of KVE over FY, ang CV natin ay equal sa 1.10 the square root of KVE over FY divided by H over TW. So, ito yung ating equation. Lastly, if yung H over TW natin ay greater than 1.37 the square root of KVE over FY, ang mangyayari, CV is equal to 1.51 EKV all over H over TW squared times FY. So, yun yung mahahanap nyo na value ng CV. So, another question. Ano yung KV? Kasi yun na lang naman yung unknown eh. Yung E, alam mo that is 200,000. Yung H over TW, alam mo, mahahanap mo yan sa Appendix A. Yung FY is depende na lang kung ano yung grade ng steel natin. So, according dito, yung KV daw is the web plate buckling coefficient and it is defined as kung ang ating beam is unstiffened web with H over TW less than 260, KV is equal to 5 except for stem of T-shapes where KV is equal to 1.2. So, kapag structural T ang pinag-uusapan natin, automatic daw na ang KV ay equal to 1.2. So, tandaan nyo yan, no? Okay? Kapag ang ating web ay unstiffened, tapos yung H over W is less than 260, which is palagi naman siya na less than 260, ang KV nga is 5. So, ganun lang yon. Next is for stiffened webs. Dito tayo. Ang KV is equal to 5 plus 5 all over A over H squared. Or, pwede din naman itong maging 5 if ang A over H is less than 3.0, greater than 3.0 or ang A over H is greater than 260 over H over TW squared. So, where A is the clear distance between transverse stiffener in millimeters, no? At the same time, yung H is yung D minus 2K nga, di ba? Maalala nyo. Di ba yung ating H is yung distance between the fillet weld toe doon sa pagitan ng flange and web. So, sige. In most cases, the selected shape is strong enough for shear. So, again, ang major factor pa rin naman talaga ng pagde-design of beam ay mga bending. Okay? Kasi yun talaga ang mas iniingatan natin. Mas common na yung structure class is mag-fail by bending. Kaya nga, the general scenario is, kalimitan yung section natin ay safe na for shear. However, kung gusto mong magpasiguro, suppose the shear plays a critical role in the section, it is recommended to place stiffener to the web to improve its strength. Kung magse-search kayo sa internet, halimbawa ito yung ating I shape, kung delikado yung section for bending, yun na nga, naglalagay sila ng mga stiffener plates dito. So, para ma-reinforce yung shear strength. And kung maalala nyo, in the previous formula, meron tayo ditong A, which is the distance between the transverse or transverse stiffener. So, yung clear distance nitong dalawang stiffener, yun na yung A. Okay, siya. Tapos yung H is, yun na nga, D minus 2K. Again, I hope that is clear. Pero again, ulitin ko nga, yung primary ano pa rin is bending. Yung primary player sa mga beams, bending pa rin. Bihira mag-fail ang section sa shear. Nevertheless, magbigay tayo ng example kung paano natin kukumputin yung shear strength ng section. Okay, so for this example, basahin ko lang. Determine the LRFD and ASD shear strength of the following shapes. So yung una is S510 by 112 of ASTM A36 steel. So syempre ang Fy nun is 248 megapascal. Then next is W610 by 82 of ASTM A992 steel. Ang Fy niya is 345 megapascal. Assume Kv is equal to 5.0. Solution tayo. Unahin ko muna yung S510 by 112. I assume na hawak nyo yung module or meron na kayong copy nun, either soft or hard copy, para magkasunudan tayo ng discussion. So from Appendix A, the properties of this shape are, so yung depth is 8 mm, sorry. The thickness of the web is 16.1 mm. So yung H over TW is 26.40. Imbis kasing computin pa natin to mano-mano, binigay naman na siya in Appendix A. So, isolve natin itong 2.24, the square root of E over Fy. Kasi 'di ba ito yung magde-determine if our shape will fall doon sa unang case or doon sa pangalawang case. So, 2.24, the square root of E over Fy, base dito, that is 63.612. Since yung H over TW natin is less than 63.612, no, ibig sabihin nun, nasa zone 1 to or category 1, as I said, okay? And since ang nasa category 1, kung babalikan nyo tong unang bahagi ng video na to, di ba nga, yung CV doon is 1.0. The LRFD reduction factor is 1.0. Tapos, yung ating ASD factor of safety is 1.5. Kailangan lang natin isolve yung nominal shear strength ng beam natin. So, the formula for the nominal shear strength is 0.6 Fy AW CV. So, 0.6 times 248. Ang AW is the area of the web. Then, multiply mo ng CV na 1. Ang lalabas is 1,217.005 times 10 cube Newton or 1,217.005 kilo newtons. So, meron ka ng nominal shear strength para mahanap nyo yung LRFD and ASD strength ng ating section. Syempre, ang gagawin mo lang for LRFD, i-multiply mo lang yan ng 1. So, that is still 2,117.005 kilonewton. Meanwhile, for ASD, which has a factor of safety of 1.5, so 1,217.005 divided by 1.5, so that is 811.337 kilonewtons. So, ayan, nahanap na natin yung shear strength ng section natin based on the provisions of NSCP. However, meron pa tong second part, yung ikalawang shape, W610 by 82. So, paano natin mahahanap yung shear strength niya? From Appendix A, correction na lang, this is W610 by 82. So, sige, paki-correction, W. Then, flash ko siya sa screen. So, i-flash ko na lang yung properties kasi you can just find this in Appendix A, no? So, I always assume na alam nyo na kung paano gamitin yon. So, the depth is 599 mm, the thickness of the web is 10 mm, and H over TW is 54.80. Now, isolve natin yung value ulit ng 2.24, the square root of E over Fy. So, ang lalabas is 2.24, the square root of 200,000 over 345. So, that is 53.933. Unfortunately, yung H over TW natin is greater than ito. So, therefore, alam mo na magfo-fall na siya sa category 2. So, as I said, yun na nga, since H over TW is greater than 2.24, the square root of E over Fy, the reduction factor will be 0.9 na. And the factor of safety will be 1.67 na. Okay, so nabago na yung ating reduction and factor of safety. Solve for the value of 1.10, the square root of KVE over Fy, and 1.37, the square root of KVE over Fy. So, hanapin natin to. Of course, ang assumption ng problem na to, ang KV ay equal sa 1. So, i-flash ko na parehas. So, just lang to, simple substitution. Sorry, ang KV is equal to 5. So, 1.10, the square root of 5 times 200,000 divided by 345, that is 59.222. And 1.37, the square root of 5 times 200,000 divided by 345, that is 73.758. Dahil yung H over TW natin, class, ay less than 1.10 ng KVE over Fy, ang ibig sabihin nun, yung CV natin is still 1.0. Again, refer ka na lang sa given module, nandoon yung pinakakumpletong explanation. Solve for the value of Vn, so which is the same formula, 0.6 Fy AWCV. So, 0.6, ang Fy is 345, the web area is 599 times 10, and CV nga is 1.00. Ang mahahanap natin is 1,239.93 times 10 cube newtons, or 1,239.93 kilonewton. However, class, despite the fact na ang CV natin dito ay 1.00, di ba nga nabago yung ating LRFD and ASD, yung reduction factor and factor of safety. So, for this case, ang LRFD reduction factor is 0.9, kaya ang LRFD strength is yung 0.9 lang ng 1,239.93. And ang lalabas sa calculation is 1,115.937. Meanwhile, for ASD, yung 1,239.93, i-divide mo lang ng 1.67. So, ang lalabas is 742.473 kilonewtons. So, dito na natatapos itong discussion ko regarding sa shear strength of section. So, thank you so much for listening, and I hope nagkaroon ng clarity regarding sa mga NSCP provisions for the shear strength. So, bye-bye!